In this video, we are going to learn together how to create, program, and test a function block diagram routine. The function block diagram is a graphical language for programmable logic controller design that can describe the function between input variables and output variables. A function is described as a set of elementary blocks. Input and output variables are connected to blocks by connection lines. The function block editor is fully integrated within Logix Designer, and now we are going to explore its main functionalities. Let's add now an FBD routine to our project by right-clicking on the main program and select Add New Routine. Assign a name to the new routine and select on the Type menu Function Block Diagram. To create the routine, click OK or press Enter on the keyboard. The FBD routine has been created. Double-click the routine to open the FBD editor. An FBD routine is usually composed by different sheets. Our routine currently contains one sheet. On the upper part of the FBD editor, we can easily spot the FBD toolbar. Thanks to this toolbar, we can magnify our logic, navigate through different sheets of the routine, and also assign a name to the sheet. Just above the toolbar, we can find all the function blocks that we could use for our routine. Let's start now by placing 2 input references and 1 output reference. The input reference supplies a value from an input device or a tag, whereas the output reference sends a value to an output device or tag. Let's select now a function block and add it to the logic of the routine. A function block performs an operation on an input value or values and produce an output value or values. In this case, the add instruction simply adds the value of source A with the value of source B. The result value will be displayed on the destination terminal of the block. Let's connect now the input references to the block terminals source A and B, and also the dest terminal to the output reference. Every sheet of an FBD routine has coordinates. This allows a user to better read and spot the function blocks. We can assign to the first input reference a tag, and in this case it has to be real. And we are going to assign a constant value to the second input reference. As we have done for the input references, we are going to assign to the output reference a real tag. When the controller executes this code, the add function will sum the add value tag with the constant whose value is 2. The result value will be stored in the tag named result. Our code is relatively simple. Let's create a short mathematical formula to demonstrate further. When a routine is composed by multiple blocks, we can determine the order of execution by wiring function blocks together and indicating the data flow of any feedback wires. If the blocks are wired sequentially, the order of execution moves from input to output. To prove this concept, from the FBD editor option, let's check Show the Execution Order to visualize the execution number of each block. To determine the order of execution, we have to verify the routine. We can now see the execution order for each block. For instance, the add function block is going to be executed first. Let's see now how to perform a Boolean expression using function blocks. We are going to select 2 input references and a Boolean AND. Each function block has a button with ellipsis. and clicking there it is possible to access the input or output parameters list of the block. In this case, the Boolean AND has 4 available inputs, and we can select which input will be visible or not. We want the AND block to have only 2 visible inputs, therefore we just unselect the N3 and 4 from the parameters list. The Boolean AND has now 2 inputs. Let's connect the inputs to the new input references, and then we will assign these references to Boolean tags. We can clearly notice that the wires associated with the Boolean tags are represented as dashed lines, whereas the wires associated with real and dint tags are solid lines. Let's complete the Boolean expression by selecting a Boolean OR with 2 inputs. We have just created a feedback loop between the output terminal of the Boolean OR and one of the input terminal of the Boolean AND. Logix Designer does not allow to perform this loop operation, and when clicking the Verify Routine button, an error is generated. To resolve this loop, we need to assume that the data is already available for the specific feedback wire. Right-click on the wire and select Assume Data Available. After verifying the routine, the error now disappears. We have seen so far how to determine the order of execution of our blocks and how to resolve a loop. Another important feature to mention is the wire connectors. These input and output connectors allow us to transfer data between sheets or in complex wiring situations. For example, if we want to transfer the result of our mathematical formula using connectors, we have to wire an output connector to the MUL DEST terminal. We need to specify a unique name for the connector. Double-click and type a name. Let's see now how to access the value of the connector that we have just created. In order to demonstrate it, we are going to name the sheet Math Formula. We are going to create a new sheet where an input connector will be placed. To create a new sheet, click the icon Add Sheet. When the new sheet is created, let's name it as Example. Here we are going to place an input connector in order to access the value of the connector named Result Sheet 1. By double-clicking on the input connector, we will have a list of available connectors. Select Result Sheet 1. We can spot a hot link just right below the input connector. This feature allows us to easily navigate between connectors. To complete our example, we are going to connect the input connector to an add block. Input and output connectors enable us to disperse data to several points in the routine in an easy and practical way. As a last step for this video, we are going to download this code to the controller and then test it. We are now online with the controller. We can easily read the values of each block and terminal. For instance, let's set the add value tag to 50 and see which result the math formula will produce. After entering the new value to the add tag, the math formula result is now equal to 235. The output connector is also reading this value. Clicking the hot link, Logix Designer takes us to the input connector. The value equal to 235 is also provided to the add block on the sheet named Example. We have seen how easy it is to create and program an FBD routine, and we recommend to adopt this programming language while dealing with process applications or drive control.